Hello everyone, welcome to lecture 16. This is increasing and decreasing functions lecture. In this lecture, we will learn how to apply differentiation rules and derivative technique to determine the interval on which the function is increasing, the interval on which the function is decreasing, or the interval on which the function is flat. And also, we will determine if a function is increasing, decreasing, or flat at a point on the graph of a function. This will build a foundation for a later lectures when we learn how to find the interval on which the function is increasing, decreasing, or flat algebraically, and also determine the maximum values and minimum value algebraically. So let me go through a few definitions before we look at examples. So the first definition is increasing functions. So it say that a function f is increasing on an open interval I if for any choice of x1 and x2 in the interval I, with x1 is always less than x2, then the height of the function at x1 has to be less than the height of the function at x2. Now, if you take a look at the graph here, by definitions, you choose two numbers, x1 and x2, for x1 is always less than x2. And you measure the height of the function at x1, you obtain f of x1. And again, you measure the height at x2, you obtain f of x2. And you show that f of x2 is greater than f of x1. In other words, the graph of a decreasing function is that the graph will slant up from left to right. Now let's take a look at the definitions for decreasing. A function f is decreasing on an interval I if for any choice of x1 and x2 in the interval. Again, in this case, we have to assume that x1 is less than x2. Then we measure the height of the function at these 2 points. We obtain f of x1 and f of x2, and f of x1 has to be greater than f of x2 in order for us to see a decreasing functions. Now let's take a look at the second graph. In this graph, again, x1 and x2, where x1 has to be less than x2, and you measure the height of the function at x1, you obtain f of x1, and you measure the height at x2, you obtain f of x2. And you can see that f of x1 is greater than f of x2. So this is a decreasing function. In other words, the graph slants down from left to right. Now, when you look at the constant function, a function f is constant on an open interval I if for all value of x in I, the value of f of x are equal. So that means when you consider any two random numbers, x1 and x2, again, here we assume that x1 is less than x2, then the height at x1 has to be equal to the height at x2. Then in that interval, the function is constant. Right? As you can see in this case, the height of the function remains the same at x1 and x2. So that means f of x1 is equal to f of x2. Then we can write this is a constant function. There are two main types of extreme values. Right? We have a maximum value and minimum value. We can identify
relative maximum, relative minimum.
Or we can look at absolute or global maximum and absolute or global minimum. All right. So by definitions, relative or local maximum is the highest point where the function changes from increasing to decreasing on an interval. So be careful here when you look at relative or local maximum and relative or local minimum, because when we look at these values, we have to consider them on an open interval. Again, relative and local minimum is the lowest point where the function changes from decreasing to increasing on an interval. When you look at absolute or global maximum and absolute or global minimum, the definition is very similar to the case of local max or local min. The difference is that you need to consider this point on the entire domain. So here's the definitions. The absolute or global maximum is the highest point where the function changes from increasing to decreasing on the whole domain. That's the difference between absolute maximum and relative maximum. Similarly, the absolute minimum is the lowest point where the function changes from decreasing to increasing on the whole domain. Because of the distinctions, there's a warning for us when you look at the relative maximum, relative minimum versus the absolute maximum and absolute minimum is that the local maximum and minimum values cannot be identified at the endpoint because they are found on some interval, not on the entire domain. We will look at the graph of some functions a little bit later to see this particular warning. But first, let's write down the warning. That is the local max and min values cannot be identified at the endpoint because they are found on some interval. Right, so let's quickly take a look at the graph of some function. Okay, so for this particular graph, we can identify the absolute maximum, absolute minimum as well as relative maximum and relative minimum. So for these 2 points, I can say these are relative maximum or local maximum. This point will give me a relative minimum. And if you compare this point on the entire domain, you will see this point will be a global minimum or absolute minimum. But at the same time, because if you consider this point on some interval around it, we can consider this as a relative minimum as well. So a point can contain both absolute minimum and relative minimum. If you think about temperature, if this is the coldest temperature in the entire world, then it should be the coldest temperature in your neighborhood. Makes sense, right? Now let's take a look at the endpoint. For this endpoint, you compare with the entire domain, you can see that the point is a global or absolute maximum. But for the left endpoint, this is not the lowest point in the entire domain. And you cannot identify the relative minimum or relative maximum at this point because on the left-hand side of this point, there is no more curve. So that means there's no interval for you to consider a relative maximum and relative minimum. So hopefully this aligns with the warning that we have a little bit earlier that you cannot identify relative maximum and relative minimum at the endpoints. So let me quickly note it here, no extreme value. So one more definition and we move on to some more examples. So turning point, it's just the general terms to say that you have a maximum or minimum, right? So turning points are points at which the curve changes from increasing to decreasing or from decreasing to increasing. So that you have either a maximum or minimum. So turning points are points at which the functions changes from increasing to decreasing or from decreasing to increasing. For the next example, we can use the graph of the functions to identify the interval of increasing, the interval of decreasing, as well as the turning points and classify the turning point to see if the turning point is a maximum or a minimum. Okay, so let's take a look at the graph here. The requirement here is to list turning points and identify if they are relative maximum, relative minimum, or absolute maximum or absolute minimum. Right, so there are a few points that we can consider. The first point is the point negative 8, negative 4. The second point is negative 2, 6. Then 0, 0, 2, 10, and 5, 0. Alright, so these are the turning points, and by looking at the graph, we can identify if it's the maximum or minimum. Right? So let me list out the points. You have negative 8, negative 4. So this point is a relative or an absolute minimum. You have negative 2, 6. This is a relative maximum. The point 0, 0 is a relative minimum. The point 2, 10 is a relative maximum. So this point cannot be an absolute maximum because when you look at the graph of the functions, the end behavior will go to positive infinity. So therefore, the point 2, 10 is only the relative maximum. And the last point on the graph that we want to look at as a turning point is 5, 0. It's a relative minimum. Next questions, by looking at the graph, we can list out the interval on which the f is increasing. So the function increasing on this interval from negative a to negative 2, from 0 to 2, and from 5 to positive infinity. That is from negative a to negative 2, from 0 to 2, and from 5 to positive infinity. A few warnings here when you write notations of interval of increasing, interval of decreasing, and interval of constant function is that you use only parentheses to describe it, and you use the x value. There's no bracket for the interval of increasing, there's no bracket for interval of decreasing, and no bracket for interval of constant functions. Okay. Now, the interval on which the function is decreasing, these are the interval. The interval from negative infinity to negative 8, from negative 2 to 0, and from 2 to positive 5. So these are the interval from negative infinity to negative 8, from negative 2 to 0, and from 2 to 5. And when you look at the graph, there's no constant part on the graph, so you can just say not available or none for the interval of constant function. Not only when you look at the graph, but also the derivative of the functions. It can tell you a lot about the behavior of the functions. When the function is increasing, it can imply that a prime has a positive value. Right? When the function f is decreasing, it can indicate that the derivative of the function is less than 0. And when f remains constant or has a flat spot or horizontal tangent line, it can imply that f prime is equal to 0. So this is called the increasing and decreasing test, and is very important to identify later the interval on which the function is increasing, on which the function is decreasing, as well as identify the maximum and minimum value algebraically. Right. But first, we look at some graphs and identify the value of the derivative based on the behavior of the functions without calculating the exact value of f prime. So let's take a look at example 2 here. So given the graph of the functions, we want to identify the value of each derivative to see if the derivative is positive, negative, or 0. So the first derivative is f prime of -3. So let's take a look at -3. So this is 0, -1, -2, and -3. At this point, the function is decreasing by the definitions we just have. When the function is decreasing, the derivative at that point is less than 0. Again, we don't care about the exact value at this moment. It's just that we want to find the sign or identify the sign of the derivative at a given point. So in this case, we have f prime of -3 is less than 0 because at -3, the function is decreasing. Next value, f prime of -2. So when x is equal to -2, the function has a flat spot or a horizontal tangent line. Because of that, f prime of -2 is equal to 0. At x equal to -1, you have that the function is increasing at that point. So f prime is going to be positive. Similarly, when you consider f prime of 0, the function at x equal to 0 is also increasing, so f prime of 0 is positive. When you consider x equal to 1, at that point, the function is also increasing, so you have f prime is greater than 0. And at x equal to 2, right here, the function has a flat spot or a horizontal tangent line. Then you can deduce that f prime of 2 is equal to 0. Hopefully, it's helped you identify the sign of the derivative of the function at a certain point based on the behavior of the original function. Okay. Now, moving on to the next example, example 3. The question is going to be very similar. That is, can you identify the sign of the derivative at the given point? Right. That means you want to look if the derivative is positive, negative, or 0, corresponding to the behavior of the function as increasing, decreasing, or constant. Right. If you want, you can pause the video a little bit and do the problem yourself, then compare the solution with mine and see what happens. For this example, we consider the functions one more time, and the derivative of the function at x equal to 1 is equal to 0, because at x equal to 1, the function has the flat spot or the horizontal tangent line. So f prime at that point is equal to 0. Let's consider f prime of 2. So that is, you look at x equal to 2. At x equal to 2, the function is decreasing. So f prime of 2 is less than 0. At x equal to 3, the function has a flat spot or horizontal tangent line. So therefore, you have f prime of 3 equal to 0. At x equal to 4, the function at that point is increasing. So f prime of 4 is positive. At x equal to 5, as you can see, there is a flat spot right here. Then f prime of 5 is equal to 0. And at x equal to 6, the function is also increasing. So therefore, f prime of 6 is greater than 0. Now let's see more behavior of the functions at some given point based on the graph of the functions. So given the graph of these functions, let's take a look at the point at x equal to -8. A few questions here. So they want you to evaluate the output or the value of the function at x equal to -8. They want to know what is f of x equal to. Is f of x positive, negative, or 0? So that means you look for the output. You look at the y value of the function. So at x equal to -8, You can see that the point is below the x-axis, so the functions is going to be negative at x equal to -8. And at the point -8, you have a flat spot, so that means it's flat. And because of that, the derivative at that particular point is going to be 0. Similarly, when you look at the point x equal to -5, you can see that the original function at x equal to -5 is equal to 0. And at that point, the function is increasing, and therefore the derivative is positive. Now at x equal to 3, you cannot even see this on the graph of the functions, but still there's a lot that you can say about this particular locations. Right? So at x equal to 3, the function stay above the x-axis, so f of 3, or the output of the function at that point, is positive. The function at this point is decreasing, and therefore the derivative is less than 0. So this at x equal to 3, the function is decreasing, therefore the derivative at that point is negative. So that's it for this lecture, and hopefully you kind of have an idea of increasing, decreasing, and constant functions, as well as how to identify the relative maximum, relative minimum, and absolute maximum and absolute minimum by looking at the graph of the function. Here we also use the graph of the functions to identify the interval of increasing, interval of decreasing, and interval of function. All right. Please let me know if you have any question. Thank you.